My name is Haigh, and I'm the project director of a new operation based in a tiny Caribbean island of Utila called Wreck Hunters. Here we aim to teach the techniques and skills of diving archaeology in crystal clear waters on an 18th century wreck in no more than 18 meters of water. A fantastic training environment. I'm here today at the SS Great Britain leaning against a Trotman anchor. Now, Trotman anchors were invented after the Great Exhibition of 1851 when a competition was run to create the best anchor that could be, and the Trotman anchor won that competition. And as part of the Wreck Hunters course, we will be teaching the recovery, the lifting, of both large and small objects. And in this session, I'll be talking about large objects, both robust, like the anchor here, but also items which are more fragile. Now, there are bigger examples of the Trotman anchor than this one. I've seen one which is 2.5 tons, about a third weightier than this one. The largest Trotman anchor ever recovered from the sea was from off the coast of Canada, from a depth of 540 meters. We will not be teaching you that, but we'll be teaching you a lot of other skills when it comes to lifting of objects. And I've been involved in a lot of my time, so I have a little bit to say about this matter. So let's go on and talk about lifting operations. For most people involved in diving archaeology projects, one of the most memorable moments is the recovery of historically significant and even valuable objects from the seabed. Now, in the UK, the recovery of objects is regulated by the Lifting Operations and Lifting Equipment Regulations of 1998. Now, although we are not commercial divers, it's a good idea to apply their standards. In this case, there are 4. 1, to plan the operation properly. 2, to have competent and experienced people involved. 3, to have those people supervised. And 4, to plan the lift safely. No sane person can argue with those principles. But when you talk to any diver about lifting, the first idea that they will have is the idea of the lifting bag. A quick visit to YouTube will show some disaster events where people could easily end up dead by getting it wrong.
Todo cuidado, tá que esse paraquedas de 500. Ok, saiu, né? Ok, esvazia. Olha aí. Solta ele aí, Flávio. Solta, Flávio. Segura. Puxa o Flávio.
So we need to spend a little bit of time talking about how to use lifting bags safely. The first key principle is to get the size of bag right. And this means you need to get the size of object you're going to raise correct, and more importantly, its weight. I have been involved in projects where people have got this horribly wrong. You need a bag which is 25 to 30% larger than the object you're going to raise. Now, the reason not to have a huge bag is because all will happen when you put the air in. Boyle's law will kick in, it will hit the surface, often breaking the surface, all the air will disappear, the lifting bag plus your prized possession will vanish into the depths, perhaps never to be seen ever again. The same problem obviously occurs when you try and get the object and the bag back into the support vessel. So it's a really good idea to have a pretty long rope that 2 or 3 people can grab hold of, so when the bag does hit the surface, they can get the line and pull it in, hence saving everything. Now, you also need to think about the ancillary equipment that goes with the lifting bag itself. You need to think about the shackles, perhaps the carabiner, and especially about the strop. Now, the guidelines are the strop needs to be a ratio of 7 to 1. So if you're going to lift something which is 50 kilograms, you need to have a strop that's got a working load of 350 kilograms. You need to think about all these things. Now, these large objects, cannon, amphora, copper and lead ingots, can all be raised using a lifting bag. And they survive pretty well when they do it. Another good idea, if you're using a lifting bag, is to have some sort of line attached to it, a sort of baseline, if you like, which means that if it should go horribly wrong and the object should start to sink again, you won't be able to stop an uncontrolled lift, obviously, but what you will be able to do is at least perhaps get back to where the object is and not lose it forever. Also, you need to think about the supply of gas, air normally you're going to use to lift the bag. Don't use your own, that would be nuts. The best thing to do is have a cylinder, 3 to 7 litre cylinder, which I would attach to the lifting bag itself with a nozzle, an inflator, now normally made of rubber so they don't perish, which inflates the bag. And if Bohr's law catches you out, the bag and the cylinder and the nozzle are heading for the surface, not you. Now, some bags do have dumps, which divers can use to control the lift. I would guard against these other than for very short distances, because again, if the bag ascends quickly, the bag will not get bent, and you will. Also remember, these things are lifting bags, not dragging bags. Some training organizations do use these as a small lift to lift a small object, say a couple of meters, that's fine. But for any distance, they really aren't a good idea. You need to lift something and put it down again if that's going to be your ideal. I've been involved in many situations where you need to move buoys on coral reefs and something being destroyed. So that type of thing. Even engine blocks work quite well for that. And those are good things to use. So be very, very careful with lifting bags. They are things that can catch you out very much. So, as I said, for fairly robust articles, they work. Alternative lifting bags involve using solid plastic drums. These things do not expand, they're set, so any excess air will simply come out the bottom and your lift will be controlled. For small objects, even potboys work. Remember also, lifting bags, they're not always just to recover an object to the surface. Sometimes they are used to make an object neutral so it can then be moved somewhere else, and then perhaps a crane or something else more appropriate could be used to lift the object. Even rope will sometimes do. Now, if we then move to more fragile objects, clearly attaching them to a balloon and sending it to the surface is not a good idea. Back in the mid-80s, the Oxford University Mare team were working on a wreck in Giglio, an Etruscan wreck from about 600 BC, and discovered a section of keel. Now, this was a unique object and needed to be treated carefully. A purpose-built box was made to fit this remnant of keel in, and then it was lifted to the surface using a series of pulleys, which worked great on the day. And indeed, for that moment, there was a great deal of media coverage. So, that covers it mainly for large objects. In our next session, we'll be looking at recovering smaller objects, specifically looking at the different types of materials involved, be they glass, metal, pottery, both coarse and fragile, and bringing you up to speed on the ways we can deal with these more delicate things. Until then, I wish you all safe and enjoyable diving.